Hi everyone, in this presentation we will be covering chapter 4.5, Add and Subtract Fractions with Different Denominators from the OpenStax Pre-Algebra textbook. Now our core learning objectives then for this video is to find the least common denominator, the LCD, convert fractions to equivalent fractions with the least common denominator, I add and subtract fractions with different denominators, identify and use fraction operations, use the order of operations to simplify complex fractions, and then finally evaluate variable expressions with fractions. So all of these are different objectives from this particular chapter here. Now I want to start with these two questions to ponder now. What is the meaning of the least common denominator? And why is this useful when adding or subtracting fractions? So go ahead and pause the video here and see if you can answer these questions before we move on from here. Okay, so first, what is the meaning of the least common denominator? The least common denominator, or LCD, is the smallest number that all the denominators can divide into evenly. So it's comparing multiple fractions, or when you add multiple fractions, then you will need to find that common denominator. The least common denominator then is the smallest, which makes it easier to simplify the fractions toward the end. Now, why is it useful? Well, it's useful when adding or subtracting fractions because the fractions must have the same sized parts. So for example, if I had the fractions 1/2 plus 1/4, currently this is not in the same size denominator, right? The same size denominator for 1/2 and 1/4 would be in fourths, right? I can actually change the 1/2 by multiplying by a factor of 2 on both the top and the bottom parts of my fraction. And this allows me to change this fraction to 2/4. That's the equivalent form of that fraction. And I can now add that. These are now common parts. They are common denominators that we can then solve. So in this case, solving this particular fraction would be 2 plus 1 is 3, and we keep the same denominator, 4. Okay, so that common denominator, least common denominator, again, keeps our numbers small. It also allows us to actually combine these fractions together. Okay, so let's go ahead and now find the least common denominator for several other fractions from here. Now let's find the least common denominator for the following fractions here. The method I have listed is the method specifically from the OpenStax Pre-Algebra textbook. Broadly speaking, this can be called the prime factorization method. There's another method called the listing of the multiples method. This is probably more common in terms of what's initially taught, and it's very useful when the numbers are small because it's a quicker method generally. But the prime factorization method is a bit more robust and it works best when the numbers get quite large. So for question 1, I will show both methods. But for question 2, 3, and 4, I will use the prime factorization method because this is really a skill that will be useful as you get into higher level math. All right, so looking at 5/12 and 1/9, let's go ahead and do the prime factorization of 12 and of 9 here. So the prime factorization of 12 then is 2 and 6. We can circle our prime factor of 2, and then 6 is going to be 2 and 3. Okay, 9 then is simply 3 and 3. So at this point, we've done step number 1, factor each denominator into its prime. Step 2, let's go ahead and list out the primes here, matching primes in columns when possible. So 9 is really 3 times 3. So I'm going to actually put this out a little bit because 12 has some 2's in there. So I'm going to have 3 and 3. And then 12 is 2 times 2 times 3. Okay. So when I find a least common multiple, this is different than simplifying, right? We're not crossing things out. We are now dropping things down from columns. So This 2 is not matched, so we're going to drop the 2 here, times drop this 2. Now, one of the 3's actually do match, so now we're basically taking out a 3. We're dropping the 2 3's down from the column, and then dropping this last 3 down as well, okay? So this is going to be our least common multiple then. So that's step 3, bring down our column. Step 4 then, multiply the factors. The product is the LCM of the denominators, okay? And then the LCM of the denominators is also the least common denominator of the fractions. So this is going to be 2 times 2, which is 4, 4 times 3, which is 12, and 12 times 3, which is 36. So the LCM here is going to be equal to 36, which that also then will be the least common denominator. So in the next series of questions, we'll learn how to then take the least common denominator and make it equivalent fraction. But in this case, that's not the skill we're learning. We're just learning how to find the least common denominator by finding the least common multiple. Okay, so that's question 1. Now, the other method to find the least common multiple, which then becomes the least common denominator, is the listing method. So if I do the listing method for question 1, this would be listing out 9 and 12 here. And then I just list out the first few multiples and see if any of these come across. So 12, we'd have 12, 24, 36, 48, 60, 72. So we're going to go ahead and stop there. And then 9, we have 9, 18, 27, 36, 45, 60, excuse me, not 60, 54, got ahead of myself, 63, there we go, and then 72. So you can see some common multiples now that have popped up in these two lists, right? I see a 36 and a 36 that pops up, and I also see a 72 and a 72 that pops up. So both of these are multiples. Both of them, by the way, can be used as denominators, but the least common denominator for this is 36. Okay, so that is the listing method, totally reasonable to use as well. Now let's look at question 2. So question 2, 17 over 36 and 1148, we are going to factor each of these denominators into its primes. So I'm going to do 36 and 48 here. Now, with all of these, there are different ways to break this down with prime numbers. You could start with 2 composite numbers, or you could start with the smallest primes. So I generally like to show the smallest primes just as one method to kind of go to. So for 36, the smallest prime is even, so we would have 2 times 18. 18 then can be broken down into 2 and 9. And 9 can be broken down into 3 and 3. Okay. So that is the first prime factorization then for 36. 48, we can break this down into 2 and 24. 12 can be broken down into 2 and 12. 12 can be broken down into 2 and 6. And then 6 can be broken down into 2 and 3. So 48 definitely has a lot longer multiple list here. Okay, so now let's go ahead and list our primes, matching the primes in columns when possible. So starting with 36 here, we have 2 times 2 times, I'm going to put the 3 out a ways, times 3. And you might have to play around a little bit with the columns, making sure that you match them up, but I gave myself some space here. And 48 then can be written as a bunch of 2's. So 2 times 2, and then I have another 2 2's, times 2 times 2, and then it has 1 3 that it can match up. Okay. All right, so then dropping our columns, we combine the ones that we have. So 2 and 2 drops down. Another 2 and 2 drops down. These 2's are not combined, so we're not basically combining them together. They'd have to match up with 36. We can match up another 3, and then a final 3. So this prime factor list then is our least common multiple, which then is our least common denominator. Okay, so we've done step 2 and step 3. Step 4, we can multiply our factors now. So we're going to do 2 times 2, which is 4, 4 times 2, which is 8, 8 times 2, which is 16, 16 times 3, which is 48, and then 48 times 3, which is 144. Now you might have to do that out by hand a little bit more, or you can bring a calculator and use a calculator for this component. And what you end up getting is 144 as your least common multiple. Now, since that's your least common multiple, this is also your, let me rewrite that. I guess we'll do that. L, which is also your LCD. So when you changed your numbers to equivalencies, you'd be multiplying by 144, which if you were to do 48, basically 48 times 3 is your 144 to get to that point, okay? All right, so let's look at question number 3 now. Question number 3 is 7 over 24 and 3 over 40, but I shouldn't write the 7 over 24. We're just going to go ahead and write the 24 and the 40. So let's find the prime factorization of both of these. So 24, we have 2 and 12. And then we have 2 and 6. And then we have 2 and 3. 40 then, we have 2 and 20. 2 and 10. And 2 and 5. So again, these are our prime factors, our prime numbers. So now let's list out our primes. So starting with 24, I have 2 times 2 times 2 times 3. And 40, I have 3 2's as well, so I have a lot of 2's that I can match. So 2 times 2 times 2. Don't have a 3 to match up, but I do have a 5. Okay, so I'll put a 5 there. Then bring down our columns. The first 2 we can bring down, times the next column, times the next column, times our 3, times our 5. Okay, so our least common multiple now is represented by this prime factorization list. So at this point now, we can do 2 times 2, which is 4, 4 times 2, which is 8, 8 times 3, which is 24, and 24 times 5, which is 120. So our least common multiple, which is also our least common denominator, in a sense, is equal to 120 here. Okay, so that is question 3. Those are some larger denominators for sure. Let's go ahead and now do question number 4, which is unique because it has 3 fractions. So when you have 3 fractions, you have to find the least common denominator that all 3 of them can change into. So if I do the prime factorization of each, 3, 4, and 16, what you'll realize with 3 is already a prime number. So I can circle that. It's 1 times 3. 4, you can break down into 2. So you can do 2 and 2. And then 16, you can break down into 2 and 8, which then you can break down into 2 and 4, which then you can break down into 2 and 2. Okay. All right, so now bringing our lists down, we have 3, 4, and 16. I'm going to go ahead and start with 16. Just it's the biggest, the longest one, and all of them are 2. So I have 2 times 2 times 2 times 2. Okay. Now 4 is going to be 2 and 2. And 3 can't be matched up with any of these, so he's going to go way over here in his own column by his lonesome. Okay, so at this point now, we've matched up our common factors. We can now bring down the columns. So the first 2 can be brought down. The next 2 can be brought down. The next 2 can be brought down. The next 2. And then finally, our 3 can be brought down as well. So now I have 2 times 2, which is 4. 4 times 2, which is 8. 8 times 2, which is 16. And 16 times 3, which is going to be 48 here. So we have a least common multiple then, which is also the least common denominator of 48. Okay, so this is the prime factorization method. It's quite useful, particularly for question 2 and question 3, I would say. Question 1 and question 4, you might actually find it easier to just do the listing strategy because the numbers are fairly small. Okay, so you can choose to go back and forth between the two methods depending on how big the denominator is as well and how comfortable you are with that method. All right, so now our next step or next series of questions will be to actually find the least common denominator and then change them to equivalent fractions. Okay, so let's convert two fractions to equivalent fractions with their least common denominator as the common denominator. So starting with question number 1, 1/4 and 2/6, we are going to find the LCD first. Now, I'll go ahead and use both methods for question 1. This is a great example of where the listing method probably is the easiest one, just because the numbers are smaller, right? But let's continue practicing the prime factorization method as well, which means we're going to do the prime factorization of 4 and 6 to start. So 4 factors down to 2 and 2. And 6 factors down to 2 and 3. So if I was to then put these into a column listing, we would have 4 and 6. 4 is 2 times 2, and 6 is going to be 2 times 3. Next, I'll go ahead and drop the column. So 2 drops down below, another 2 drops down, and then a 3. So our LCD or LCM is 2 times 2, which is 4, 4 times 3, which is 12. So for question number 1, 12 is our result. Now, if I wanted to do the listing method, I could list out the multiples of 4 and 6. The multiples of 6, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36, so on and so forth. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and 4 times 6 is 24. So if I look at this listing then, we see a 12 and a 12, and a 24 and 24. So these are common multiples. The least common multiple then again is the number 12. Okay, so we're going to use 12 as our LCD. Step 2 then, for each fraction, determine the number needed to multiply the denominator to get the LCD. So I have 1/4 and 2/6 here. So the number we need to multiply 4 by to get to the LCD is a 3. And the number I need to multiply 6 by to get to the LCD is 2, right? 4 times 3 is 12, 6 times 2 is 12. Step 3, use the equivalent fractions property to multiply both the numerator and denominator by the number found in step 2. So in other words, for 1/4, whatever I multiply in the denominator, according to the equivalent property, I would need to now multiply in the numerator. So 4 times 3 and 1 times 3, and 2/6 then would be 2 times 2 and 6 times 2. So then completing this, we would now have 3 over 12, and we would have 4 over 12. Okay, so 3/12 and 4/12 is our result for question number 1. Question 2, we have 8/12 and 1/14. So for the 8/12, let's go ahead and do the prime factorization of 12, and then also the prime factorization of 14 for the 1/14. So 12 is going to be 2 and 6. So circle the prime number 2. And then 6 is going to be 2 and 3 here. Again, circle the 2 and the 3. 14 then is going to be 2 and 7. Okay, so 2 and 7 is the prime factorization of those numbers. So then rewriting this below, we have 12 and we have 14. So 12, if I was to rewrite the prime factors, are 2 times 2 times 3. And then 14 is going to be 2 times 7 on the other side here. Okay. So then combining our columns, the 2 and 2 can drop, times another 2, times 3, times our 7 as well. Okay. So this is now going to be our least common multiple, or least common denominator, I should say. So 2 times 2 is 4, 4 times 3 is 12, and 12 times 7 is 84. So a larger number. This would have taken a bit more doing in terms of the listing of multiples potentially. So this might be a useful strategy for these two. So 84 is then our least common denominator. So let's go ahead and go to step number 2 now. So for each fraction, determine the number needed to multiply the denominator to get to the LCD of 84. So I have 8 over 12 and 1 over 14 now. So for 8 over 12, the number that I'm multiplying 12 by to get to 84 is 7. So I'm going to multiply this by 7. And then for 1/14, the number I'm going to multiply by is the number 6 here. So this might take a little scratch work on the side, by the way. If you're doing some kind of guess and check, that's one strategy you can utilize as well. Step 3 then, use the equivalent fractions property to multiply both the numerator and the denominator by the number found in step 2. So 8/12, since I multiplied 12 by 7, I'm now going to multiply that same factor for the number 8 here. So I do 8 times 7 now over here. Whatever I do in the bottom, I need to do to the top number as well. 14 times 6 then is the denominator here. So I'm going to multiply 1 times 6 above here. So completing the equivalent fraction property now, I'm going to do 8 times 7, which is 56, and 12 times 7, which is 84. And then I'm going to do 1 times 6, which is 6, and 14 times 6, which is also 84. So now 6 over 84 is my result for the second fraction. Okay, so that's question 2. Let's look at question 3. So question 3, we have 7/18 and -5 over 24. So the negative really doesn't have a bearing in terms of actually finding a common denominator in a sense. But we do need to remember to put the negative back when we've done the equivalent fraction rule. All right, so let's first start by finding the LCD by doing the prime factorization of 18 and 24. So the prime factorization of 18 then is going to be 2 and 9. Could also be 3 and 6. And then 9 is going to be 3 and 3. Okay. 24 then, we have 2 and 12. 12 can then become 2 and 6. And finally, 6 can become 2 and 3. So I've done the prime factorization of 18 and 24. Now let's go ahead and line them up. So 18, I have 2 times 3 times 3. Actually, let me give myself a bit more room here because I noticed for 24 there's some more than 2 2's, right? So let's go ahead and give some blank column space. And then for 18, we'll write 3 times 3 here. Okay. So 24 then, we have 2 times 2 times 2. Okay, so I gave some space now. And then I have another 3 left over. Okay, so now when I match up my columns, I can match up the 2 and the 2 times another 2 times another 2 times a 3, oops, a 3 times another 3. Okay, so now multiplying this out, 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, 24 times 3 is 72. Okay, so 72, that is going to be our least common denominator here for question number 3. All right, so let's go to question 2, or step 2. So now let's find the equivalent property or equivalent fraction of 7/18 and -5/24, knowing that we will have a least common denominator of 72. So the number I multiply 18 by to get to 72 is going to be the number 4. And the number I multiply by 24 to get to 72 is 3. Now, using the equivalent fractions property, whatever I multiply in the denominator, I need to multiply in the numerator. So 7 times 4. And then likewise, I have 5 times 3 here. So then completing this fraction, 7 times 4 is 28 over 72. And this one is 15 over 72. And of course, this is a negative as well. Okay, so negative 15 over 72 is my result for question 3. Okay, let's go ahead and look at the core part of this video now. Add and subtract fractions with different denominators, starting with question number 1, 2 7ths plus 1/4. And we're going to start by finding the least common denominator once again. So I'm going to do the prime factorization of 7 and 4. 7's already a prime number, so I can circle this number. 4 then is 2 and 2 here. So if I circle this and this, we now have our prime factors. Now what's interesting about this, do you notice how none of these prime factors are the same? That basically means I can't combine anything. So really, all I'm doing is multiplying 7 times 4 in this case. But just to kind of confirm the pattern, 4 and 7. So 7 is really 1 times 7 if I put a 1 in there. And 4 can be 1, I kind of did this out of order, times 2 times 2. So if I brought all of these down here, 1, 7 times 2 times 2, again, you don't really need to put the 1, by the way. 7 times 2 is 14, 14 times 2 is 28, or you could say 2 times 2 is 4, 4 times 7 is 28. In both cases, our LCD is a number 28 here. Okay, so next, we can convert each fraction to an equivalent form with the LCD as the denominator here. So if I have 2 7ths and 1/4, what I'm doing in this case is I am multiplying my 7 by a 4 and multiplying my 2 by a 4. And then for the 4, I'm multiplying this by 7 and this by 7. This allows me to get that least common denominator of 28, right? So my fraction now would read 2 times 4 is 8, 7 times 4 is 28, and then 1 times 7 is 7. 4 times 7 is 28. So then rewriting this in the horizontal addition form, we'd have 8 over 28 plus our 7 over 28. Now we go to add and subtract our fractions, so 8 plus 7 is 15, and 28 stays our denominator here. So I now have 15 over 28 here. Then our final question is, can we actually simplify these numbers down? Well, let's go ahead and check what our prime factors are and see if there's any common prime factors. If there is common prime factors, then yes, we would be able to simplify. Well, the prime factors of 15 are going to be 3 times 5 here, while the prime factors of 28 are going to be 2 times 2, which is 4, times 7, which is 28. Do you see any common factors here that we can simplify or eliminate? You don't, right? So this tells us that 15 over 28 is the most simplified form. There is no number we can simplify into it or divide into it. It's also a proper fraction, meaning the top number is smaller than the bottom number, so I cannot convert this to a mixed fraction either. So 15 over 28 is my result. All right, let's look at question number 2 now. 3/5 plus 2/7. So our first step, let's find the least common denominator. Now what's interesting about this one again is 5 and 7 are both prime numbers. So in reality, I could go and list these out, I guess, in that same manner, but these are each in their own unique column here. So when I drop them down, I'm just multiplying these two numbers against each other. That's our least common denominator now. So 5 times 7 then is 35. So 35 is our LCD. So then converting the fraction to an equivalent form with the LCD as the denominator would look like this. So 3/5 and 2/7. I'm going to multiply the 3/5 by a 7 in both the denominator and in the numerator, while the 2/7 I'm going to multiply by 5 and 5 here. So completing this equivalency, we now have 21 over 35, and we have 10 over 35. So let's go ahead and now write it horizontally. It's 21 over 35 plus 10 over 35. Adding our two numerators, we now get 31, and we keep 35 the same. Now, can we simplify this? Well, 31 is actually a prime number. The only numbers that can divide into 31 are 1 and 31, while 35 is broken down into 5 and 7. So none of these are common factors, which tells us that 31 over 35 is our most simplified version here. It's also a proper fraction. The top number is smaller than the bottom number, so I cannot convert it to a mixed fraction. Let's go ahead and look at question 3 now. So question 3 is now a subtraction problem. The process, though, is the same in that our first step is to find the least common denominator. So let's go ahead and do the prime factorization of 6 and 10 now. So 6 is going to be 2 and 3. And 10 is going to be 2 and 5. So if I list these two numbers out, 6 and 10, we have 2 times 3, and 10 is 2 times 5. Now you might already notice, not even having to write these columns out, you might already notice what's the combined element here. So 2 can combine into 1, drop down to 3, drop down to 5. Our least, oops, that's not a 5, that's a 3, right, a 5. Okay, Chris, there we go. we have 2 times 3 times 5, so 2 times 3 is 6. 6 times 5 then is 30. So the least common denominator for 5/6 minus 3/10 is a 30. So now, step 2, let's convert each fraction to an equivalent form. So I'm going to multiply 6 times 5 to get to 30, and 5 times 5 to keep the equivalency. And then 10 I'll multiply by 3 and 3. So my equivalent fractions would now read 25 over 30 and would read 9 over 30. So now let's go ahead and subtract it. So let's be very careful on the order here. So I have 25 over 30 minus 9 over 30 here. Okay, so completing this, we can subtract our numerators. 25 minus 9 is 16. Subtract and keep the same denominator. Don't want to subtract our denominators. And we get 30. Okay, so we now have 16 over 30. And now can we simplify this? Well, we can, right? If I was to write out our prime factors, we would have 2 times 2 is 4, times 2 is 8, times 2 is 16. And then 30, we have 2 times 15, which is also 2 times 3 times 5, right? 2 times 3 is 6, 6 times 5 is 30. Now let's look at the common factors. The common factors we see are a 2 and a 2, right? So at that point then, our simplified version, since we have now taken out one of the 2's, it's just multiplying the rest. So 2 times 2 is 4, 4 times 2 is 8, and then 3 times 5 is 15. So our simplified version is 8/15. So this is how kind of the OpenStax textbook really shows simplification. The other structure you could show, if in case you didn't want to rewrite them as the prime numbers, you could say, oh, okay, I know these two numbers are even, so I could divide both the top and the bottom by a factor of 2, and I get 8 over 15 after dividing by that factor of 2. So that's completely fine as well. Okay, let's go to part 2 for adding and subtracting fractions with different denominators, and we're going to use some bigger numbers. So this is definitely a little bit harder task just because the numbers get a little larger, but I wanted to make sure that we see some of the larger numbers and kind of get an understanding of how to complete these as well. Really, the steps are the same though, in that we're going to first define what our least common denominator is. So I'm going to do the prime factorization of 26 and 48 to help us calculate that least common denominator. So the prime factorization of 26 then is 2 and 13. So 13 is a prime number along with 2. So 2 times 13, and then 48, a little bit longer. It's going to be 2 and 24. If I start with the smallest one, then 24 is 2 and 12. And then 12 can be 2 and 6. And then 6 is 2 and 3. Okay. So then lining up our columns, 26 and 48. 26 is 2 and 13. Now I'm going to go ahead and give myself a pretty big gap here because 13 is the biggest of all the factors here, and 48 has a lot of little small factors. So we have 2 times 2 times 2 times 2 times 3 for that 48. Okay, I don't need that last dot. So really the only two factors that are common that we're combining down are these two 2's here. So the rest we do have to drop down. So 2 drops down, and then we have another 2, 2, 2, 3, and finally that 13. So then what I'm doing here is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48. So I'll combine all these, and then I'll do the bigger one, 48 times 13. So if you want to do scratch work off the side of the page, you can for this. But 48 times 13 then becomes 624. So the LCM for this, or least common denominator, LCD, is 624. So that's a pretty big denominator, right? All right, so let's go to step 2. So step 2, we're going to convert each fraction to an equivalent form with the LCD as the denominator. So we have 13 and 26 and 25 and 48. So how you can attack this problem is you can kind of do a little bit of guess and check, probably some scratch work where you round these. So for example, for 48, you might round to 50, for example, and then you might say, okay, how many times does 50 go into 600? That would give you kind of a ballpark area of it to see, okay, what would I multiply it by, right? So some guess and check. But for our purposes, I'll let you kind of do the guess and check to figure out what factor it is. The factor, though, that 48 goes into 624 then is going to be a factor of 13. So 48 times 13 will be 624. So you can check that in your calculator as well. 25 then is also going to be multiplied by 13. Okay, so 48 times 13 and 25 times 13. If you're doing it by hand, this might take a little bit of time to get to that place. 26 then is going to be 24, and 13 is 24 as well. So that gets us to 624. So if I complete the equivalencies here then, what I end up getting in this case is 312. So 13 times 24 is 312. And 26 times 24 is 624. Basically half of 624, right? And then 25 times 13 is 325 and 624. Okay. So that's step number 2 now. Step number 3, we're going to add 312 and 624 plus 325 and 624. All right, so then at this point, we can add our two numbers together. We get 637 and we get 624 here. Okay, so this is actually both an improper fraction, which we can convert, and it's also something that we can simplify down here. Okay, so this one, again, some big numbers here in this case. So it might be useful to do the prime factorization of both numbers and then write them as a list or columns and see which ones you can eliminate. So in this case, we're not combining lists, we're eliminating some common factors here. So let's go ahead and do that for 637 and 24. So I'm going to eliminate this stuff up here and give us some more room. Okay, so let's first go ahead and start with the prime factorization then of 637. So the prime factorization of 637 is going to be 7 is the smallest prime number of 637 and 91. So you could test 2, you could test 3, you could test 5, none of those go into it. The smallest though is 7. 91 then can be broken down into another 7 and 13. So in other words, the prime factorization of 37 is going to be 7 times 13. Now obviously this will take a little bit longer to get there, but some guessing and checking and whatnot can help you figure out those prime numbers. So 624 then, this has a much larger factor tree. If I started with the smallest one, this would be 2 and 312. That's a fairly straightforward one because it's even. And then if I did an even one again, so I could keep factoring out those 2's. So this would become 2 and 156. 156 could then become 2 and 78. We still got even factors. 78 can then become 2 and 39. All right, so now we've gotten to an odd factor. Can't factor another 2, but 39 can be factored by a 3 and a 13. So at this point, you might actually now see which is a common factor between that. That's the 13s, right? Now, if I was to list these out though, 2 times 2 times 2 times 2 times 3 times 13, and I was to compare these, and when I'm simplifying, I'm just eliminating factors, I can see that I'm eliminating a factor here, 13, and eliminating another factor here, 13. So then my actual numbers would be 7 times 7, which is 49, and then 2 times 2 times 2 times 2 times 3, or 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 3 is 48. So I get 49 over 48 here. Or if you would prefer to structure it by showing a division of a factor, you can simply divide both the top and the bottom by that common factor of 13. And again, you would get to 49 over 48 here. Now 49 over 48 is simplified. This can also be changed to a mixed fraction though. In terms of a mixed fraction, if I was to divide 48 into 49, 48 goes into 49 one time. 1 times 48 is 48. 49 minus 48 is 1. 1 is now my numerator, and 48 stays my denominator. Okay, so that's the mixed fraction form for that problem. Let's now go to question 2. Okay, next we have question 2, which is negative 31 over 48 minus 17 over 36. So let's again find our least common denominator for this. The negatives will have a bearing when we actually do the numerator, the subtraction of the numerators, but for the first 2 steps, those negatives really don't have too much bearing. Okay, so starting with 48 and 36 then, 48 can be factored down to 2 and 24. So this is actually the same exact one as question 1. 2 and 24, 2 and 12, 2 and 6, and then finally our 2 and 3. 36 then can be factored as 2 and 18, 2 and 9, and then finally 3 and 3. All right, so that's the prime factorization for both of these numbers. Let's go ahead and list them now, and now compare the columns, drop the columns down. So we have 36, 48. Writing out 36, we have 2 times 2. If I compare the other list, I see another couple 2's for 48, so I'm going to give us some space to put those 2's. 3 times 3. And then for 48, we now have 2 times 2 times 2 times 2 times our 3. So now dropping down our columns, we can drop down the first column, that's that 2. This next 2. And then we have some uncovered 2's that I still need to drop down. So those 2 and that 2. Then a 3, one of the 3's basically is taken out. And then finally the other 3 after that. So now we have 2 times 2, which is 4, 4 times 2, which is 8, 8 times 2 is 16, 16 times 3 is 48, and then 48 times 3 is 144. So our least common denominator for this is 144 here. Let's now convert each fraction to an equivalent form with the LCD as the denominator. So I have 31 over 48 now. That's a negative fraction. And I have 17 over 36. That's the positive form of the fraction. And what we are now going to multiply this by is 48 times 3 to get to 144, and then multiply that by 3. And then for 1736, I'm going to multiply this by 4 and this by 4. So then rewriting it in its equivalent form, 31 times 3 is 93. And 48 times 3 is 144. 17 over 36 then changes to 17 times 4 is going to be 68. And 36 times 4 is equal to 144. Okay, so now rewriting this very carefully with this one in particular, we have a negative 93 over 144 minus a 68 over 144. Now this is interesting because of the negative and then the minus symbol. So I would like you to now basically isolate, just kind of pay attention to the numerators now. So negative 93 minus 68. If I'm to think about, okay, what does this mean? Let's draw our number line just to model it. So 0, not to scale or anything, but we have negative 93. So if I think about it in terms of money again, negative 93 is like negative $93 in debt, right? If you then subtract the positive 68, this is like you spending another $68. You're spending the 68 positive dollars that you had, but now you're going further in debt essentially. Okay, so I'm going back to the left then, a total of 68, going back to the left, a total of 68 units. Meant to write that up here. And then where I end up is at a negative 161 here. Okay, so negative 161 is going to be in the numerator now. And negative 144, or excuse me, not negative. I already put the negative there. So negative 161, and then 144 is in the denominator here. Okay. Now, what's interesting about this, negative 161 over 144, this is already as simplified as you can go. So the only thing we can do with this is we can change it to a mixed fraction, right? Where I'm going to divide 144 into 161, which goes in one time. So 1 times 144 is 144. 161 minus 144 then is 17. So 17 becomes your new numerator, and your denominator stays 144. And since this was a negative improper fraction, it stays a negative mixed fraction as well. Okay, so that's question 2. Let's go ahead and take a look at question 3. So question 3 then is going to be negative 9 over 28 minus negative 5 over 12. And again, I want to find the least common denominator to start. So I'm going to go ahead and do the prime factorization of 28 and 12. So prime factorization of 28 is 2 and 14. 2 times 14 is 28. And 14 can be broken down into 2 and 7. And 12 can be broken down into 2 and 6. And then eventually down into 2 and 3. Okay, so then if I was to line these up, 12 is going to be 2 times 2 times 3. 28 then is going to be 2 times 2 times 7. So dropping these down, I have 2, another 2, a 3, and not a 2, and a 7. Okay, so 2 times 2 is 4, 4 times 3 is 12, and 12 times 7 is 84. Okay, so our LCD for this one is equal to 84. Okay, so step number 2, let's convert each fraction to an equivalent form. So we have negative 9 over 28. We're going to convert that, and we're also going to convert negative 5 over 12. So the factor we need to multiply 28 by to get to 84 is a 3. And I'll also multiply the 9 by 3 now. And then the number I'm going to multiply 12 by is a 7. And I'll multiply the 5 by 7 as well. Okay, so rewriting my new fractions, I have 27 over 84, negative. And I have 35 over 84, and that's also negative. Okay, so now I'm going to write this horizontally here. We have negative 27 over 84 minus a negative 35 over 84. Okay, so now we have that common denominator. Let's isolate those numerators so we can really see what we're actually doing. So we're doing negative 27 minus a negative 35. Okay, so in this case, if you model this on the number line, we start at a negative 27. So if I think about it in terms of money, negative $27 of debt. Then I am subtracting a negative 35. Well, subtracting a negative is the same as adding a positive. I'm increasing my value essentially. If I think about it in terms of money, it's like you taking away debt, taking away $35 in debt. So I'm going back to the right on the number line by 35 units here. And I'm basically looking at what's the difference between 35 and 27, which is 8 here. So it takes me 27 units to get back to 0. It's 27 units from here to here. And then I have another 8 units basically to go after that. Okay, so my answer, my numerator then is actually a positive now. And it's a positive 8 over 84 here. Now for this one, you might recognize that, these are two even numbers, so I could divide and simplify these by an even number 2. So I could break these up into prime number factors. I'll go ahead and show the other method where we can divide into chunks if we wanted to. So let's divide by even numbers, 2 and 2. So 84 divided by 2 is equal to 42. And 8 divided by 2 is equal to 4. And then I'm going to divide by another 2, because I recognize that they're still even. So another 2 and another 2. And what I end up getting is a 2 over a 21 here. Okay, so our answer for this is 2 over 21. The next section is to identify and use fraction operations, in which in the following exercises we're performing the indicated operations and writing it in simplified form. So this skill is really to ask us to see they're similar fractions, the same fractions in fact, but depending on the operation, you will do a slightly different technique. So, or not a slightly different technique, you will do a different technique, right? So question 1 then, we have 3/4 plus 1/8. So in this case, what we're asked to do is to add our fractions. And to add our fractions, we first need to find a least common denominator and then add our numerator. So in this case, 3/4 and 1/8, I'm going to do a little shorthand method, not as long as some previous ones. 4 goes into 8, right? So 4, the 8 is a multiple of 4. That means that we only really need to change one of these fractions here. So The factor I multiply 4 by to get to 8 is a factor of 2. Whatever I then multiply in the bottom part of the fraction, I need to multiply in the top part of the fraction. So 3 times 2 as well. So rewriting my new fraction, I would have 6 over 8 plus 1 over 8. I then add my numerators, 6 plus 1, which is 7, and I keep the same denominator, which is 8, so 7 over 8. I then ask myself, can I simplify this? Well, I can't simplify this, right? There's not a factor that is going into both 7 and 8, right? So this is as far as I can go. Question 2 then, I should say the question 1, the second part of question 1, is now asking us to divide these two fractions. So when we divide, this is where I use the shorthand technique, or the kind of a mnemonic in a sense, of keep it, change it, flip it, right? Find the reciprocal, in other words, of the right side fraction. Okay, so if I do follow this rule set, I keep 3 over 4, I change my division to multiplication, and I flip 8 over 1. So in other words, dividing by a fraction is the same as multiplying by the reciprocal of that fraction. That's what that's showing here. Next, I recommend simplifying to start. This keeps the numbers a little smaller, so we can simplify by cross-reducing, looking diagonally and seeing, can we reduce it? And in this case, we can. So I can't reduce 3 and 1, but I can reduce 4 and 8 by a factor of 4. So I could divide both 4 and 8 by that factor of 4, and then rewriting my fraction, I now have 3 over 1 times 2 over 1. Then I multiply my numerators. 3 times 2 is 6. I multiply my denominators. 1 times 1 is 1. And 6 divided by 1 is equal to 6. Okay, so that's question 1. You can see the difference between adding and dividing and where we end up. Let's look at question 2, which now is asking us to subtract and to multiply. So we have negative 3/7 minus a positive 2/5. So again, our first step is to find a common denominator. In this case, a common denominator for 5 and 7, well, is 35, right? 7 and 5, key thing to note, these are both prime numbers, so I don't really need to do the prime factorization. If they're both prime numbers, you have to multiply them by each other, essentially. So 35 is going to be our least common denominator. So I'm going to multiply 7 times 5 here, and 3 times 5. 7 times 5 is 35, 3 times 5 is 15. Likewise, 5 times 7 is 35, and 2 times 7 is 14. So I can rewrite these fractions now as negative 15 over 35 minus a positive 14 over 35 here. Okay, so my next step then, I'm going to go ahead and subtract my numerators. Now in this case, there's some negatives here. So when there's negatives at play, I like to kind of just isolate the integers. Makes it a little easier on the brain perhaps. So what does this actually mean? Negative 15 minus a positive 14. So if I go to my number line and model this, I start at negative 15, and then I'm subtracting a positive 14, meaning I'm going back to the left on the number line 14 units, and I end up at a negative 29. So my numerator in this case is going to be a negative 29 over a 35 here. Now, negative 29 over 35 cannot be simplified. The basic reason for that is 29 is a prime number. So I'll go ahead and do the factors of this. 29 is 1 times 29, and the prime factorization of 35 is 5 times 7. Do you see how there are no similar factors? That means I can't simplify that any further. So negative 29 over 35 is my result here. Going to the other indicated operation, we have negative 3/7 times 2/5. So in this case, When I'm multiplying, the first step I always like to look at is, can I cross-reduce? In this case, 3 and 5 and 2 and 7 cannot be. So then I just go to multiplying my numerators, 3 times 2, which is 6, and multiply my denominator, 7 times 5, which is 35. Now this is also a negative by a positive. When I'm talking about multiplication or division, a negative by a positive gives you a negative result. Then I ask myself, can I simplify this? Well, the factors of 6 are 2 times 3, and the factors of 35 are 5 times 7. 5 times 7 being 35. You see how there are no common ones? So I can't simplify any of those out. So I am just left with 6 and 35 as my result here. The next section is to use the order of operations to simplify complex fractions here. So I'm going to follow the steps where I'm first going to simplify whatever's in the numerator of the fraction, then the denominator, then I divide the numerator by the denominator and simplify if I can. So if I look at question number 1 here, this is interesting because I have some exponents at play. I have 3 to the third power plus 5 to the second power, and then I have 3/4 to the second power here. So in this case, what I'm going to do is I'm going to go ahead and do scratch work. I'm going to do some scratch work side of the page. And I'm going to do the numerator first here. So I'm going to do 3 to the third power to start. So 3 to the third power really is going to be 3 times 3 times 3, which 3 times 3 times 3 is equal to 27, right? And then I'm going to do 5 to the second power, which 5 to the second power is really 5 times 5, which equals 25 here. So if I was to rewrite that into my numerator here, this really is 27 plus 25 over my 3 to the 4th power squared. Now 27 plus 25, if I did that over here, is equal to 52. So the numerator part is equal to 52 over 3 to the 4th power squared. Now the 3 to the 4th power squared part is, in this case, you are essentially writing 3 to the 4th power as multiplied by itself, right? So I can't cross-reduce these, so I'm just going to multiply my numerators. So 3 times 3 is 9, and 4 times 4 is 16. So now I have 9 over 16 here. So this would then be written, or looks like this, 52 over 9 over 16 here. Okay, so I'm running out of room. I'm going to go ahead and eliminate the things above this and in the scratch page and bring this up. So now with this complex fraction, we have 52 in the top part of the numerator and 9/16 in the denominator. And this looks like a complex fraction. So we are now going to divide the numerator by the denominator. So how we do this is I would now write this horizontally. So I have a whole number 52. I would structure this as a fraction as over 1, divided by now 9 over 16 here. Now I'm just treating this as if I'm doing dividing of fractions, which means I'm going to keep the 52 over 1 the same. I'm going to change the division to multiplication, and I'm going to flip 9 over 16 to become 16 over 9. Then I'm going to go ahead and see if I can cross-reduce. Well, for 52 and 9, there's not a common factor, nor is there 16 and 1. So I just need to now multiply my numerators and multiply my denominators. So 52 times 16 then is equal to 832. So that's a very large number, over 1 times 9, which is 9. Now, 832 divided by 9 does not have a common factor. So 9 can't be divided by 2, and since 3 and 9 does not also go into 832, this is actually as simplified as you can go. Now, you can change this, though, to a mixed fraction. In mixed fraction form, this would become 92 and 4/9 here. Okay, so that is my answer for question number 1 here. Question number 2 then is 4 to the third power minus 4 to the second power, and then I have 2/5 squared in the denominator here. Okay, so basically, actually I don't want to do that. Let's do some scratch work on the side here. So we're going to do 4 to the third power, which is 4 times 4 times 4, which is going to be equal to 64. And then we have 4 squared, which is equal to 4 times 4, which is equal to 16. Okay, so at this point then, if I was to rewrite this, I have 64 minus 16 over 2/5 squared. 64 minus 16 then is going to be 48. Okay, now let's go ahead and do the 2/5 squared part, which is really going to be 2/5 times 2/5. So 2 times 2 is 4. 5 times 5 is 25. So we get 4/25 as the bottom part of this complex fraction. So now I'm going to rewrite this horizontally. So I'm going to write this as 48 over 1, structure the whole number as a fraction, divided by 4 over 25. Then I'm going to find the reciprocal and change the division to multiplication. Keep it, change it, flip it. So 48 over 1 times 25 over 4. Now in this case, this can be simplified. I can divide a 4 diagonally into both 4 and also into 48. So rewriting 48 divided by 4, I get to 12 over 1 times 25 over 1. So 12 times 25 now, our numerators, is 300. 1 times 1 is 1, so 300 divided by 1 then is equal to 300. Okay, so this is using order of operations to simplify complex fractions. The last section for this presentation is to evaluate variable expressions with fractions. So let's start with question number 1 here, where we're asked to evaluate the expression x plus 3/4. And we're asked to do that for 2 separate variables here. So let's first start with the initial variable, x equals -1/8, which means we are going to substitute or replace the x variable. So I can replace that with -1/8 here, plus a 3/4. Okay, so now we need to find a common denominator here, and a common denominator for 4 and 8 is going to be the number 8, right? So 4 goes into 8, so we just need to actually change the 3/4 fraction here by multiplying it by a common factor of 2 and 2 in both the top and bottom parts of our fraction. So we now have -1/8 plus 6 over 8 here. Okay, so now we have our common denominator of 8, so we're just looking at our numerator. So we're now having -1 plus 6. We're adding a positive 6. So if I look at my number line here, and I'm just paying attention to the numerators now, we have -1, and we're going back to the right on the number line, 6 total units, and we end up at a +5. So our answer for this first variable is going to be +5/8. Let's look at the second variable now. So we have x plus 3/4, and now we're asked to solve when x is equal to negative 7/4. So I am going to again replace the x with negative 7/4. What's interesting about this one is we already now have a common denominator, so I don't need to change or do that initial step I did in the negative 1/8 example. At this point now, I'm just doing negative 7 plus 3, so I'm paying attention to my numerators. If I go to my number line and draw this out, I'm starting at negative 7 here, and when increasing by 3, I go back to the right, again, 3 units. And where I end up from negative 7 is then at a negative 4. So my numerator is then going to be negative 4. My denominator is also positive 4. Now this is an improper fraction that can be reduced down, and it can be reduced down to a 1. 4 divided by 4 is 1, and it's a negative by a positive, so it's a negative 1. So that's question number 1. Now let's look at question number 2. So question number 2 is to evaluate the expression x minus 3/7. And we're going to evaluate this when given x is equal to 5/7 for the first one. So again, I'm going to replace the x variable with 5/7 minus 3/7. In this case, again, we're given a common denominator. So all I need to do then is subtract my numerators. So 5 minus 3 is going to be 2, and we keep the same denominator, 7. Now 2/7 cannot be reduced down because there's not a common factor between 2 and 7. Rewriting our expression again, x minus 3/7, we are now going to replace the x variable with negative 2/7 minus 3/7. Again, we already have a common denominator, so now we are doing negative 2 minus 3/7. So if I go to my number line here, and I'm just paying attention to the numerators, this is negative 2 is our starting spot, and then we're subtracting 3, which means we're decreasing in value by 3 units. We're going back to the left 3 units. And where I end up is then at a negative 5. So rewriting this, I have negative 5 in the numerator, and I have 7 in the denominator. Okay, so that completes our presentation. Again, we covered chapter 4.5, adding and subtracting fractions with different denominators. We looked at how to find common denominators and convert fractions that need to be converted to equivalent fractions with our least common denominator. We then looked at adding and subtracting fractions and different order of operation type problems. Okay, so I'd go ahead and get into the OpenStax Pre-Algebra textbook. You can find that textbook linked in the description below. If you have any questions, feel free to drop it in the comment. Otherwise, I'll see you guys next time. Good luck and thanks.